Malaysia. Rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Salam sejahtera dan hai semua para guru, ibu bapa dan semua pelajar sekalian. Selamat datang ke Pusat Tuisyen Akademi Youtuber dengan usaha sama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Cikgu perkenalkan diri dahulu. Nama Cikgu P kini mengajar di Oleh Tingkatan 6 Tun Fatimah selaku moderator pada petang ini. Pada petang ini, kita akan bersiaran langsung dari channel Cikgu Hasnitah. Siapa yang belum subscribe, silalah tekan butang subscribe sebagai tanda sokongan kepada Cikgu Hasnitah. Nama sebenarnya beliau adalah Hasnitah binti Andy Banyo dari Tawau Sabah, kini mengajar di SMK Bagan Jaya Batawu. Kita akan belajar subjek tingkatan 5 Fizik dengan tajuk Einstein'S Photoelectric Theory, iaitu tajuk yang terakhir untuk tingkatan 5. Kelas ini akan bersiaran langsung secara 1 jam. Turut berada di konti ialah Cikgu Rosemawati dari SMK Bandar Minturu Sarawak selaku control host pada petang ini. Sebelum kita teruskan kelas, suka cikgu ingatkan kepada semua pelajar dan penonton yang ingin menghantar komen. Sila gunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Cikgu percaya semua yang hadir kelas pada petang ini merupakan pelajar-pelajar cemerlang dan mari kita tunjukkan disiplin yang terbaik. Link e-sijil akan diberi pada hujung siaran nanti. Pastikan anda isi dalam tempoh 30 minit selepas kelas tamat. Link e-sijil boleh diisi dengan email e-didik, email my guru, email Jawi dan email e-didik. So sila fokus pada isi kandungan yang akan disampaikan oleh Cikgu Hasnitah. Semoga kelas kita pada petang ini dapat dimanfaatkan sepenuhnya oleh para pelajar. So dengan ini, Cikgu serahkan kelas kepada Cikgu Hasnitah. Silakan Cikgu.
Okey, terima kasih sahabat saya Mr. P selaku moderator kita pada petang ini. Begitu juga kita ada Cikgu Yani dari SMK Bandar Bintulu Sarawak selaku control host. Terima kasih menemani saya di konti pada petang ini. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan selamat petang saya ucapkan kepada semua anak-anak pelajar yang cikgu kasihi di mana jua anda berada. Begitu juga dengan guru-guru ataupun ibu bapa yang mungkin ada mengikuti kelas kita pada petang ini. Jadi alhamdulillah sekali lagi kita akan bersiaran secara langsung dari channel YouTube Cikgu Hasnitah selama lebih kurang 1 jam untuk kita bincangkan tajuk yang terakhir ya Mr. P untuk tingkatan 5 ini iaitu 7.3 teori Photoelectric Einstein. Okey, sebelum itu cikgu kongsikan dahulu slide cikgu. Okey, cikgu yang ni boleh tunjukkan paparannya. Dan sebelum itu marilah kita mulakan kelas dengan umur kita Al-Fatihah bagi yang beragama Islam. Yang bukan Islam bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Okey, jadi anak-anak pelajar sebelum itu Syahyin mungkin boleh respon kepada cikgu. Boleh dengar cikgu dengan jelas tak Syahyin? Kalau boleh tuliskan dekat chat tu boleh cikgu. Okey, jadi satu lagi peringatan buat anak-anak, nota anda boleh muat turun pada link yang cikgu pinkan di ruangan chat itu, dalam bentuk PDF copy boleh dimuat turun dan boleh juga dicetak keluar untuk digunakan di sepanjang kelas ini bersiaran, ataupun anda boleh tengok dahulu, nanti boleh cuba semula latihan tersebut. Okey, jadi tanpa membuang masa, cikgu mulakan dahulu dengan jadual kita pada minggu ini. Telah berlangsung pada Jumaat yang lepas ya Mr. P. Kelas untuk tingkatan 4 iaitu disampaikan oleh Cikgu Rosemawati 5.5 pembelawan gelombang. Jadi siapa yang terlepas kelas ini jangan risau, anda boleh tonton semula di channel Cikgu Rosemawati ataupun tonton dari portal Akademi Youtuber di www.akademiyoutuber.com. Dan petang ini cikgu akan sambung tajuk 7.3. Sebenarnya ini adalah sambungan daripada apa yang telah disampaikan oleh Mr. P dalam kelas minggu lepas 7.2 kesan fotoelektrik. Okay students, ini adalah barisan guru-guru sukarelawan fizik di Akademi Youtuber yang telah banyak menerbitkan video-video untuk membantu anda untuk memahami subjek fizik ini dengan lebih baiklah. Jadi anda boleh layari pautan yang tertera pada skrin ataupun boleh scan pada QR code di sana. Gunakanlah video ini sebaiknya, dan di apps anda juga, di Android anda boleh muat turun juga apps yang kita beri nama Akademi Youtuber ya cikgu, Mr. P dan Cikgu Yani. Apps ini ada lebih kurang 20,000 video PDPC yang anda boleh gunakan sebagai bahan ulang kaji atau rujukan. Daripada kita ada daripada prasekolah sehinggalah ke pra-universiti, dan untuk SPM kita ada hampir keseluruhan subjek lah ada. Jadi anda boleh muat turun di Google Play Store anda sekarang juga sekiranya tidak muat turun lagi. Okeylah. Jadi okey Cik Ayin boleh dengar, terima kasih respon. Okay, so students, if you are ready and good to go. So this is 7.3 Einstein'S Photoelectric Theory will be conducted in DLP, presented by me Cikgu Hasnitah from SMK Bagan Jaya. So our first learning standard is to state, okay, what is the minimum work function needed by a metal to emit an electron by using this equation, promoting by Einstein, HF equal W plus half mv squared. So kita akan belajar satu persamaan di sini untuk menyatakan fungsi kerja minimum yang diperlukan oleh satu logam bagi memancarkan elektron. Okay, so kalau anda follow kelas Mr. P minggu lepas, okay, anda sepatutnya sudah tahu apa maksud kesan photoelectric. What is the definition for photoelectric effect? Okay, so I begin with this slide. So this is what we learned before. Einstein applied Max Planck idea of energy quantum. So if you remember what said by Max Planck, he said that energy quantum is in a form of discrete energy, tenaga yang discrete. Okay, and then Einstein suggested that the energy is carried by particle called photon. Tenaga dibawa oleh partikel yang kita kenali sebagai photon. So dalam photon ada apa? Dalam photon ada tenaga kuantum. Okay, so photon is the carrier for the quantum energy. Okay, and student will learn this before. So energy carried by each of these photon is directly proportional to the frequency of the light. Okay, and can be determined by this equation. So you have found this equation in 7.1 before. Kita sudah gunakan persamaan ini pada, kalau anda ingat subtopik 7.1 ya, persamaan Planck inilah. E ini energy for photon, H ini is the Planck constant, and F ini is the frequency of light. Okay, dan seterusnya. Okay, kita masuk kepada tajuk. Okay, this is our the gist of the content for this topic. Okay, and as I mentioned before, in 7.2, you've learned last week with Mr. P on photoelectric theory. You have learned what is the definition for photoelectric effect, and also the four characteristics of photoelectric effect. So in 7.3, we will focus on the photoelectric equation, okay, promoting by Einstein, and then we will check on the photoelectric current production by solar cell, and a few applications of photoelectric effect, and last but not least is to solve a few problem related to this topic. Okay, let us begin with Einstein. As I mentioned earlier, so Einstein said each quantum of light is a discrete packet of energy. Discrete mean they exist in a small packet of energy. Okay, and there are many packets of energy in a beam of light that shine on a metal surface. Okay, and this process begin when a photon arrives surface. When we shine or radiated light sources on a metal surface, energy inside the light will be fully absorbed electron in the metal. And when the energy is enough for them to come out, so they will escape from the metal surface as an photoelectron. So itu yang berlaku di permukaan logam apabila disinari dengan cahaya pada satu frekuensi yang tertentu. Okay, and then students later, this energy will use to release the electron, or known as photoelectron, from the metal surface. And the extra energy will become their kinetic energy. Okay, so elektron yang terkeluar berjaya melepaskan diri daripada permukaan logam, mereka akan keluar dengan satu jumlah tenaga kinetik yang kita boleh hitung menggunakan formula dia seketika nanti. Okay, and usually the electron on the metal surface, as you can see in this GIF, will acquire maximum kinetic energy compared to the electron at the level. So elektron yang di permukaan tu dia akan memperoleh tenaga kinetik maksimum yang lebih dah berbanding dengan dalam. Okay. Okay, now in this diagram we will see the comparison. Okay, when and will the electron will be emitted from the metal surface when they are irradiated by photon or light sources. Okay, if you look at the first diagram, okay, before that there's a notes up there. Electron will be emitted if only the photon energy of the ray exceed the energy of the metal bond or the metal work function. Okay, if you look at the first diagram, we irradiate a photon in the surface, but you can see there is no photoelectron emitted from the surface. So from here, what do we understand? The energy of the photon is lower, okay, than the work function of the metal. So not enough energy to make the electron come up from the surface. Tak cukup tenaga untuk mengeluarkan elektron daripada permukaan logam. So you will see no electron emitted in this case. And in the second situation, what happened? Okay, now the energy of the photon is equal, okay, just enough. Maknanya cukup saja, sama dengan fungsi kerja logam, enough with the work function of the metal. So at this rate, the electron emitted with zero kinetic energy. Ada elektron yang keluar tapi dia tak ada kinetic energy. Okay, because the energy supply is just enough, okay, to emit them but not to move or to get mobile anyway. And in the third situation, now you can see that the energy is now greater than the work function of the metal. Tenaga yang dibekalkan oleh foton sekarang adalah lebih tinggi daripada fungsi kerja logam. So pada ketika ini, elektron itu berjaya dikeluarkan daripada permukaan. Bukan itu saja, dia akan bergerak dengan satu halaju yang maksimum ataupun tenaga kinetik yang maksimum. So at this rate, and the energy of the photon is greater than the work function of the metal, so the electron will be emitted with the maximum kinetic energy. So I hope you can differentiate these three situations. What happens when the energy of the photon is lower than the work function of the metal, what happens when the energy is equal, and what happens when the energy is greater than the work function. Okay, students. Okay, then okay, so as the electron emit from the metal surface with a high amount of kinetic energy, so this is the photon, the equation that relate the photon energy and the kinetic energy of the photoelectron release just now. Apa berkaitan tenaga foton yang kita bekalkan, yang kita sinarkan kepada logam dengan tenaga kinetik elektron yang terbebas. So this is the formula. Photon energy is equal to the minimum energy required to release photoelectron, or known as work function, plus the maximum kinetic energy of the photoelectron. Tenaga foton, simbol dia E, sama dengan fungsi kerja logam. Tenaga minimum yang diperlukan untuk melepaskan fotoelektron tambah dengan tenaga kinetik maksimum fotoelektron yang terbebas. So elektron yang bebas tu kita panggil dia sebagai fotoelektron. Okay. And this equation we can expand into the second equation where E equal to HF. So E can be written in terms of HF Planck constant multiplied by frequency of the photon. Again, on the right side, W is the work function, and maximum kinetic energy, this is the equation half mv squared. If you remember, students, this is the formula for kinetic energy, half mv squared. Okay, so this is what we call as an Einstein photoelectric equation. Inilah yang kita panggil sebagai persamaan fotoelektrik Einstein. Nanti kita akan guna dalam menyelesaikan soalan yang berkaitan dengan topik ini. And when we shift the places, kita ubah saja make the kinetic energy as a subject. So this will be the final equation. Okay, half mv squared max equal to hf minus the work function w. Okay, and another information, this Einstein photoelectric equation, it is accordance with the principle of conservation of energy. Okay, if you remember, energy cannot be created or destroyed, but it can be convert from one form to another. Okay, so boleh faham macam mana kita terbitkan, bagaimana kita dapat lihat persamaan Einstein itu. Okay, then students, okay, next, okay, at the threshold frequency. Okay, later you will find this term. Apa itu frekuensi ambang? Okay, at the threshold frequency, photoelectron are emitted without any kinetic energy. So this is what happened in the second situation previously, which I show you. Apa yang berlaku apabila E sama dengan W, when the energy of the photon equal to the work function. Okay. So this is the equation. Okay, the kinetic energy of the photoelectron released or emitted is 0. So we can write this equation like this: kinetic energy 0. So this is the energy of the photon. Okay, energy of the photon. H itu is the Planck constant, and F naught, this is the threshold frequency. Okay, multiply minus with the work function. So you can see there is a note there. What is threshold frequency, students? It is the minimum. Okay, minimum frequency required to produce photoelectric effect on a metal. Threshold frequency of what? Of the photon. Okay, of the light radiated. Okay, mean the minimum frequency to emit electron from the metal surface. Okay, then when we arrange this formula, so it becomes the work function equal to the energy of the photon, energy of the photon reply or energy of the photon on the threshold frequency. Okay, fungsi kerja sama dengan tenaga foton pada frekuensi ambang. Okay, boleh faham And when we substitute this equation into Einstein equation earlier, so what happened? This is what you are going to get. Okay, the kinetic energy, maximum kinetic energy of the photoelectron equal to the energy of the photon minus energy of the photon at the threshold frequency. Okay, dia punya formula yang ini. Okay, when we simplify the equation, so it becomes half mv squared max equal to h f minus f naught. Okay, ini kalau anda diberi beberapa soalan lah. Okay, because the frequency provided can be at a different value, so we can see what is the difference when on the emission of the photon, when the photon supply at different value of frequency. Apabila kita sinarkan photon pada frekuensi yang berbeza, kita akan dapat lihat kesan yang berbeza pada penghasilan fotoelektron, sama ada atau tidak, ataupun mana yang hasilkan lebih banyak fotoelektron, mana yang hasilkan lebih sedikit. Okey, kita teruskan Mr. P. Harapnya pelajar boleh follow lah sampai setakat ni. Okay, then students. Okay, so this is again electron. Okay, remember students, electron can only be emitted from the metal surface when the photon energy is exceeded the work function. Ini daripada yang tadi lah kita highlight sekali lagi. Elektron boleh terbebas daripada permukaan sekiranya tenaga foton yang dibekalkan itu melebihi fungsi kerja bagi sesuatu logam. Okay, dan tenaga yang berlebihan itu akan ditukar kepada tenaga kinetik untuk elektron yang terbebas. Okay, so again this is the energy of the photon, so equal to the work function of the metal plus the maximum kinetic energy of the photoelectron released from the surface. So ini ada kesamaan yang seterusnya lah yang anda boleh gunakan, okay, in problem solving involving to this topic later on. Okay, kita tengok seterusnya Mr. P. Okay, so I'm done with 7.1. So let us do one question on 7.3.1. Okay, very simple question student. You just have to state the Einstein photoelectric equation. Okay, tadi cikgu sudah bincang formula dia. So you can write on the blank spaces in the PDF copy provided. Okay, cikgu ni boleh tunjukkan sekali lagi link dia. Anda juga boleh dapati link tersebut pada deskripsi video inilah. Okay, so this is Einstein photoelectric equation. HF refer to the photon energy, which is E. W is the work function, and this is the maximum kinetic energy of the photoelectron released from the surface. So this is the explanation for istilah HF, photon energy. W, minimum energy required to release a photon, or also known as the work function of the metal, fungsi kerja logam, iaitu tenaga minimum yang diperlukan untuk membebaskan fotoelektron daripada permukaan logam. And this is the maximum kinetic energy of a photoelectron. Okay, tenaga kinetik maksimum fotoelektron yang terbebas daripada permukaan logam tadi. So the equation again, HF equal W plus half mv squared. Okay. Okay, then done with the first part, Mr. P. So I think we can move to the second learning standard. And students, if you have any question to ask, kalau ada apa nak tanya, anda type saja pada live chat, or you can also respond to my question. Jangan malu, jangan segan Okay, student, we move to our second learning standard is to explain what is threshold frequency and work function. Tadi cikgu ada sebut beberapa kali frekuensi ambang dan fungsi kerja. Okay, sekarang kita nak tengok dengan lebih detail apa maksud kedua-dua terms ini. Okay, so first, work function. What is work function refers to? It is referred to the minimum energy required for a photoelectron to be emitted from a metal surface. Dia adalah tenaga minimum yang diperlukan oleh untuk photoelektron terlepas keluar daripada permukaan logam apabila disinari dengan cahaya. Okay. Yang kedua, okay, this is the second term, threshold frequency. Okay, is the minimum frequency. Yang cikgu garis itu is the keyword. Okay, so the minimum frequency for a light photon to produce photoelectric effect. Dia adalah frekuensi minimum bagi sesuatu foton ataupun cahaya yang kita sinarkan tu untuk menghasilkan kesan fotoelektrik. Kesan fotoelektrik ni maknanya kita berjaya keluarkan elektron daripada permukaan logam. Okay, so remember, work function is the minimum energy required. Meanwhile, threshold frequency is the minimum frequency required for a light photon. Okay, so these two is a very important definition. Kalau boleh anda kena ingatlah. Okay, ingat dengan baik supaya kalau keluar dalam soalan you can write the full definition for both. Okay. Okay, and next, okay students, okay, this is the graph which actually you can find in your textbook. It shows the relationship between the maximum kinetic energy of the photon. Remember, the maximum kinetic energy is when E is greater than W. Okay, when that photon energy greater than the work function of the metal. So the photoelectron emitted with the maximum kinetic energy. So maximum kinetic energy is directly proportional. Bukanlah directly proportional, it increases. Okay, from this graph, it shows the relationship between maximum kinetic energy and the frequency of the photon, okay, irradiated on the surface. So this is the pattern of the graph. You will see that the graph is a straight line graph, but it does not started from the origin. Dia tidak melalui asalan, okay, and it has a positive gradient. Dia ada keturunan yang positif, okay. So this is how we identify or get to know with the graph of Kmax against F, okay. And if you look there, there is one mark there marked with F naught. Okay, so what is F naught? This is the threshold frequency, okay, of the photon irradiated on the metal surface. F naught ini adalah nilai frekuensi ambang. Okay, kita boleh lihat dia pada lintasan paksi X. Okay, on the X intercept of this graph, mean at the frequency intercept. Okay. Okay, then students, okay, let us check on the second graph. Actually, this is the same graph but have been prolonged. So it is now intercept at the y-axis, you can see down there. Okay, so from Einstein equation, we check on earlier where E equal to W plus K max. E itu again is HF, photon energy, equal to work function and maximum kinetic energy of the photoelectron. So when we arrange this formula in accordance with this graph, where Kmax is the y-axis, so we bring the Kmax to the left side, make it the y-axis. So what we have on the right side of this equation, we have HF minus W, okay, where F is the x-axis, which means H is the gradient of this graph, where H itu is the Planck constant. So what is W, student? W is the y-intercept. So correct. Okay, y is the work function and it is determined from the y-intercept of this graph. Okay, so now it is accordance with the linear equation for graph linear motion. Graph y equal to mx plus c. So y axis represented by maximum kinetic energy, the gradient is the Planck constant H, and x-axis is the frequency, y-intercept is the work function. Okay, so you can fill up the blank spaces with the correct answer. What is the intercept on the frequency axis? This is x-axis, so it is the threshold frequency, okay, threshold frequency F naught. And the y-intercept of this graph, so y-intercept give you W, this is the work function of the metal. Meanwhile, the gradient, as I mentioned, it is represent the Planck constant, which is 6.63 times 10 negative 34 joule second. Okay, so boleh faham graf ini senang saja. Paksi Y mewakili apa, paksi di manakah kedudukan frekuensi ambang dan di mana anda boleh baca nilai fungsi kerja bagi sesuatu logam. Okay, and from this graph, this is what we can conclude. The higher the threshold frequency, the higher the work function. Apabila frekuensi ambang sesuatu logam meningkat, fungsi kerja dia juga semakin meningkat ataupun bertambah. Okay, Mr. Peh, let us now do some question on checkpoint 7.3.2. If you can understand me, if you can follow me, so I believe you can answer these questions. Baru saja kita bincang tadi the definition for work function and threshold frequency. Okay, students. So again, what is work function? It is the minimum energy required for who? For photoelectron to be emitted from a metal surface. Nilai tenaga minimum yang diperlukan oleh fotoelektron untuk terlepas daripada permukaan logam. Okay. Then second, what is the definition for threshold frequency? Apa maksud frekuensi ambang? Minimum frequency for a light photon to produce photoelectric effect. Frekuensi minimum, okay, yang diperlukan oleh foton cahaya. Ini apa itu foton cahaya yang kita sinarkan kepada permukaan logam untuk menghasilkan kesan fotoelektrik. Then what is the relationship between these two? Apa hubungan di antara kedua ini? Kita telah lihat dalam graf tadi. They are we can write the relationship as this: the higher the threshold frequency of a metal, the higher the work function. Semakin tinggi frekuensi ambang sesuatu logam, semakin tinggi fungsi kerja logam tersebut. Okay, so this is how we write definition and relationship between work function and threshold frequency. Okay, done with the first two learning standard. Okay, now Mr. Pei, Cikgu Yani, okay, let us move to the third one, to determine work function. Okay, we understand what is work function. Kita sudah faham apa itu fungsi kerja, iaitu tenaga minimum, okay, yang diperlukan untuk membebaskan elektron daripada permukaan logam. Then now how to find, macam mana kita nak kira menggunakan formula W sama dengan HFO. So this is the formula you can determine to determine work function of a certain metal. Okay, we check on this graph first. Graph ini anda boleh jumpa dalam buku teks juga sebenarnya. Okay, so this is a graph of Kmax, maximum kinetic energy of a photoelectron against a frequency of photon. Okay, so we have three metal there: metal A, metal B, metal C. So this is the threshold frequency of each. Okay, threshold frequency for metal A, the red line itu threshold frequency for metal B, and the blue line is the threshold frequency of metal C. Okay, and if you look at this graph, they all have the same gradient, where the gradient represent Planck constant. Maknanya Planck constant itu dia tetaplah, okay, same gradient. Okay, so what do we understand from this graph, student? The first one, photoelectron will acquire kinetic energy when light frequency exceed the threshold frequency. Okay, photoelectron dia memperoleh tenaga kinetik hanya apabila frekuensi foton itu melebihi frekuensi ambang logam. Okay, ingat and then second, from this graph you can see or from the previous graph, the higher the threshold frequency of a metal, the higher the work function. Logam yang mempunyai frekuensi ambang yang tinggi juga mempunyai fungsi kerja yang lebih tinggi. Okay, then so when the work function is higher, apa maksud dia? Kalau fungsi kerja itu lebih tinggi, maknanya lebih banyak tenaga minimum yang kita perlukan untuk menghasilkan kesan photoelectron. So when the work function is higher, it means that we require more minimum energy so that the photoelectric effect can occur. Okay, so ini yang pentinglah yang anda boleh faham daripada the graph ini. Okay, now how to determine, students, the work function of a five example of metal here. Okay, so you are given 4 types of metal labeled as Ta. This is titanium, molybdenum, palladium, and plutonium, and this is the threshold frequency for each. Okay, this is for example the first one 1.03. Don't forget that this one all power by 10 to the power of 14 hertz. Okay, and you have to find, your work is to find the work function for each by using this equation. Anda kerja kamu kirakan, kirakan fungsi kerja bagi setiap logam tadi menggunakan formula ini. Okay, W equal to H F naught. W is the work function, H ini is the Planck constant, and F naught ini is the threshold frequency. So when you use this equation, the work function will be in a unit of joule. Okay, mari kita kira bersama-sama. So formula dia guna yang ini saja. So H ini is a Planck constant. I give you the example for the first metal, then you can find for another 4. So this is the equation, W equal to HF. So Planck constant ini 6.63 times 10 negative, betul ke negative 14 Planck constant? Macam silap saja cikgu ni. Actually 6.63 times 10 negative 34, right? Planck constant, betul lah? Value saya silap. Betul Mr. Pei, Cikgu Yani? Planck constant negative 34, right? So ini anda boleh betulkan lah. Okay. Sini supposed to be negative 34. Okay, betul tak Planck constant? Negative 34, is it?
Ya, negative 34.
Okay, so silap lah cikgu punya ni. Anda boleh betulkan lah. Okay, then multiply. This is the threshold frequency for TA. So you akan dapat berapa? Okay, if you calculate, okay, I count back from my answer because I use wrong prefixes there. Supposed to be negative 34, but I typed there negative 14, so you can correct them. So the first one, answer supposed to be, okay, I count back for you and multiply with the threshold frequency. So supposed to be the answer is 6.83 times 10 power of negative 20. Di belakang ni cikgu betulkan dulu Okay. I think I make a correction first on my slide.
should be-
Okay, then students,
sorry,
you can determine the others. Okay, you can calculate the others.
The H is negative 34.
Yeah. Okay, this one negative 34. All here are wrong lah. Supposed to be all negative 34. Never mind, I correct them first. Okay, this one also Planck constant negative 34. Okay. So this one finally the answer will be all multiplied by 10 negative 20. Okay.
Negative,
Correct, right?
48.
Betul, right?
I think it's 48, is it?
Okay.
Oh, yang belakang itu power 14. Bukan
Power?
negatif 14.
Okay. Okay, so the final answer ini ada additional lah di sana. Okay, negative 20 joule. Okay, right? The final answer. Okay.
Frequency wavelength suppose is 10 power 14, is it? According to your...
Yeah.
No,
This one, sorry, 14. Positive 14. Sorry.
Yeah, okay. So it's correct already.
Okay. So now correct already. So all the final answer is multiply 10 negative 20. Alright. Okay. So you can check, students, either you are agree with my answer or you get different one. Boleh semak kamu dapat sama tak jawapan dengan cikgu, atau you dapat soalan jawapan yang berbeza. Okay, Jai, also you can take your calculator and try to determine all this value. Okay, so I show you back my slide. So this is the correction I have made on how to find the work function for all these 5 example of metal we are given here. So the first one, okay, so this is the Planck constant. So this is the threshold frequency for the first metal. So the work function is 6.83 times 10 negative 20 joule. And this is for the second metal, Planck constant, and this is the threshold frequency. Don't forget the power there, 1014. Okay, and this is the third metal, Planck constant again, multiply with the threshold frequency. So we'll give you 7.36 times 10 negative 20 joule. Okay, and the fourth one, Planck constant again, this is the threshold frequency, give you 8.22 times 10 negative 20 joule. And finally, Planck constant again, the threshold frequency for the fifth metal, so give you 9.02 times 10 negative 20 joule. So senang saja, so you just apply the formula and use the correct substitution, Planck constant, and also the threshold frequency. So we'll give you the work function for each in a unit of joule. So jawapan anda, tulislah unit dia bersama, okay, joule, okay. Okay, so I hope you can try this later, students. For those who cannot follow this live section, you can follow the ulang siar later on, okay, the repetition. So I think we take a short break for a while, Mr. Pei, before we continue with the next learning step.
Okay. Okay, so masalah kita berehat sekejap. Okay, so jangan ke mana-mana. Kembali selepas ini. Okey, so baiklah. Jom kita teruskan bersama Cikgu Hasnitah. Silakan Cikgu.
Okay, thank you, Mr. Pei. Alright, students. So we have finished discussed the first three learning standard. The first one, to write the formula for Einstein equation, where HF equal W plus half mv squared. What is HF? Energy of the photon. And what is W? The work function of a metal. And half mv squared is the maximum kinetic of energy of the photoelectron released from the metal surface. And second, we have checked on what is the definition for work function and threshold frequency and the relationship between both. Okay, and just now we have calculate how to find the work function of a metal, macam mana nak hitung fungsi kerja sesuatu logam menggunakan formula W equal HF0, pemalar Planck darab dengan frekuensi ambang. Okay, now in the fourth learning standard, let us try to solve a few problems by applying again Einstein photoelectric equation, HF equal W plus half mv squared. Okay, senang saja. Okay, the first question. Okay, you are given cesium, okay, with the work function 3.43 times 10 negative 19 joule. Okay, if a photon is irradiated on the surface of this cesium metal with a frequency of 7.8 times 10 power of 14 hertz, so what is the maximum kinetic energy of the electron emitted from cesium? Okay, so first and foremost you must understand what are you dealing with. Kena faham dulu soalan tanya apa. Kita ada cesium, sejenis logam dengan fungsi kerja seperti yang diberikan. Kemudian kita sinari dia dengan satu cahaya ataupun foton. Okay, dan frekuensi cahaya tersebut adalah 7.8 kali 1014 Hz. So kita nak hitung apa tenaga kinetik maksimum elektron ataupun fotoelektron yang terbebas daripada permukaan cesium. Okay, so I think you're clear with the question and you are given with the Planck constant 6.63 times 10 negative 34 joule second. So you write all the information given. Catat dulu apa informasi yang diberikan. So you are given with F, the frequency of the photon. Okay, the work function of cesium, okay, and this is Planck constant. So we are looking for Kmax. Kita nak hitung Kmax. So how to relate all this information to find Kmax? Then this is the equation we are applying. Einstein photoelectric equation. HF, energy of the photon. W is the work function of cesium, and this is the kinetic energy of the photoelectron we are looking for. So your next task is to do the substitution. So since we are looking for Kmax, we can shift Kmax to the front. So we change the equation into Kmax equal HF minus W. So this is just simple mathematics, changing the places. So please be aware with the positive and negative sign. Okay. So how to find Kmax? So we do substitution on Planck constant H. So this is the value for Planck constant. F is the frequency of the photon radiated on the cesium surface, and minus with the work function of cesium. Okay, can you help me to calculate this? Okay, you can take your calculator. So we do this together. So what is your answer? Chia Ying, Chia Yao pun boleh cubalah. Okay. Boleh cuba jawab. Okay, boleh cuba hitung. Okay, I give you a few seconds for you to try before I show you my answer. Then later you can compare. Siapa yang sudah hitung, boleh tunjukkan jawapan. Don't be shy, jangan malu, jangan segan. Kalau jawapan anda salah, nanti cikgu tunjukkan. Kalau tak sama, anda boleh hitung semula. Then you can see where is the mistake. Itu cara kita belajar, one way to learn the concept well. Okay, so are you done calculating these, students? So this is the value for Planck constant, the frequency of the photon, and this is the work function of cesium. Okay, so when you calculate, okay, so you will end up with 1.7414 times 10 negative 19 joule. Okay, anda juga kira lah, mana tahu jawapan cikgu silap kan, dan sometimes tekan calculator pun tak betul because we are dealing with a very big or small number here. Okay, so do you agree with my answer? 1.7414 times 10 negative 9. So what important here, your final answer, remember, must be at least 2 decimal places. We remind you for so many times. Penting jawapan anda kalau dalam fizik paling kuranglah kita letak 2 tempat perpuluhan. Di sini cikgu letak 4. Okay. And don't forget the final unit is crucial, very important, mandatory. Tak ada unit, tak ada markah untuk jawapan cikgu Cikgu Yani untuk format KSSM ini. So anda kena berhati-hatilah di sana. Even though 1 mark is very precious nowadays. So the answer is the maximum kinetic energy for the photoelectric release here is 1.7414 times 10 negative 19 joule. Okay. Okay, we check on the second question. Kiat Hong dapat. Okay, Kiat Hong get the same answer with me. But don't forget the joule at the back, Kiat Hong. Okay, very good. Alright, 1.74 times 10 negative 19 joule. Okay, next students. The second question, you are given a graph. Okay, a graph of K and then against frequency. Okay, a graph of K against frequency. Okay, so this figure shows the change in kinetic energy for photoelectron released from the platinum for different light frequency. The first question, you have to determine the threshold frequency from the graph and find the work function. Okay, anda kena hitung berapa dia punya frekuensi ambang dan macam mana kita nak kira fungsi kerja bagi logam platinum. Okay, so where can you find the threshold frequency from this graph? Okay, so remember just now you can find the threshold frequency from the x-intercept of the graph. So inilah dia punya x-intercept. If you can read the value there. Okay, 1 is here, so this is 2, mean at the center is 1.5, so this is 1.1, 1.2. So our point there is 1.2. Don't forget to multiply with the power 10 power of 15. Okay, so that is the threshold frequency. F naught, the threshold frequency 1.2 times 10 power of 15 Hertz. Boleh dapat Okay, then how to find the work function? Macam mana nak hitung fungsi kerja? Apa formula yang kita nak gunakan? Okay, so if you remember just now, this is the formula to find the work function when you are given the threshold frequency. Say W equal HF naught. So again, substitution. Masukkan saja nilai pemarah Planck you are given there with the Planck constant 6.63 times 10 negative 34. And this is the threshold frequency. Okay, Hertz. Hertz is mean per second. And Planck constant is joule per second. So our final unit will be joule for the work function. So you will end up with 7.956 times 10 negative 19 joule. Ini jangan round off dia pergi jadi 8 Ada kadang-kadang pelajar jadi 8 kali 10 negatif 19. Salah lah. Okay, at least remember at least 2 decimal places. So you can write 7.96 times 10 negative 19 together with the unit there, joule. Okay, so boleh soalan nombor 2 senang saja. Okay, next Mr. P, Cikgu Yani, we move to the third question. Okay, now again we have cesium. Okay, now they give you a cesium metal with a work function of 2.1 electron volt. Okay. The question is, what is the maximum velocity of photoelectron emitted when blue monochromatic light? So this is our photon with the wavelength 4.8 times 10 negative 7 meter is irradiated on the surface of cesium with this work function. Okay, soalan ni agak susah tapi tidaklah susah sangat sebab dia panjang sikit cara nak kira dia. Is a bit complicated but not very difficult actually. So anda kena hitung hal laju maksimum fotoelektron yang dipancarkan keluar daripada permukaan logam cesium apabila cesium disinarkan dengan satu cahaya monochromatic berwarna biru dengan panjang gelombangnya ini 4.8 kali 10 negatif 7 meter. Dan diberi sekarang fungsi kerja cesium dalam unit EV 2.1 EV dan sini ada satu information lah, 1 EV bersamaan dengan 1.6 kali 10 negatif 19 joule. The 1 EV equivalent to 1.6 times 10 negative 19 joule and this is the mass for 1 electron 9.11 times 10 negative 31 kb. So this is fixed, ini telah diberikanlah nilai yang tetap. So how to do this? So This is the equation we can use to solve. Again, Einstein photoelectric equation. HF is the energy of the photon, W is the work function, but this work function must be in joule. Okay, the work function, it must be in joule. You are given in EV, mean you have to convert first EV to joule to be used in this equation. So Kmax. Okay, so this is the solution I show you, student. So in this question, you are not given with frequency but we are given with wavelength. Okay, kita tak diberi frequency, kita diberi panjang gelombang. So F ini can be written in terms of C over lambda. Okay, kalau anda ingat kan, okay, if you remember, F equal C divide by lambda. Okay, so F ini can be represented by C divide lambda. So we use this substitution, okay, for F. So W is the work function in joule. Okay, this one. Okay, so this is H, the substitution Planck constant. This is the speed of light, 3 times 10 to the power of 8. And this is the wavelength of the photon given in the question, 4.8 times 10 negative 7. Okay, so on the right side, the work function, okay, 2.1 EV. So how to convert into joule, multiply with this 1.6 times 10 negative 19. So this is to convert from EV to joule. Okay, and this is the kinetic energy. So half, this is the mass, given mass for 1 electron, and this is the V squared. Okay, don't forget the square there. So it's a little complicated calculation, but as I mentioned, it's not difficult at all as long as you press your calculator in the right way. Bila anda tekan calculator, kena hati-hatilah sama ada anda selesaikan satu-satu lah. You solve on the left first and then you solve on the right, and only you find the square root for V. Don't forget to find the square root for V. So this is the velocity for the photoelectron release from cesium's surface. Okay, dapat tak jawapan yang sama dengan cikgu, 4.15. So I round up to 2 decimal places, 4.15 times 10 power of 5. Again, the unit for velocity, meter per second. Okay, meter per second. Okay, students. So the keyword is here. Okay, F represent by C divide lambda, and this one is to convert EV into joule. Kalau dia bagi dalam joule tak perlu convert dah. But now the question give us in EV, electron volt, so we have to convert into joule. That only can be applied in this equation. Okay, so 4.15 times 10 power of 5 meter per second. Okay, so I hope you're clear with this. So we can move to our next question. If you miss the full answer, don't worry, later you can check back on this video to jot down all the full answers. Okay, no worries. Okay, we move to question 4. Students, okay, again, we have a piece of metal. Now we have lithium, okay, irradiated with purple monochromatic. So this is our photon, purple monochromatic light ray with the frequency. The first one is 7.25 times 10 14, and the second frequency is 7.48 times 10 14 hertz. Okay, produces maximum kinetic energy K and 2K respectively. So this is K part question. They give you 2 wavelength and kinetic energy for both K for the first wavelength and 2K for the second wavelength. Okay. Then what is the value of K in the unit of EV? Dia minta kita hitung nilai K dalam unit EV. Okay. So don't worry. So what you need to do first, extract all the given information. So you're given with the F1, F2, the first frequency, the second frequency, and this is Planck constant. And again, we are given the substitution for 1 EV equal to 1.6 times 10 power of negative 19 joule. Okay, so how to do this? Any idea? Macam mana nak selesaikan soalan ni? Okay, kita tengok. Again, we apply Einstein photoelectric equation. HF equal W plus K max. So what to do next? Okay, so students, this is the energy, Planck constant. Okay, so this is the first frequency F1. Okay, and on the right side, W plus K. Why K? Since they give you for the first frequency, the kinetic energy is K. So K max is K. Okay, and for the second, for the second frequency, this is the formula we can apply. We can write Planck constant. This is F2, the second frequency, 7.08 times 1014. And on the right side, W is the work function. Work function is the same because lithium, okay, lithium. Then this is the energy, 2K. Okay, the maximum energy when the frequency is 7.48 times 1014 is 2K, it's stated here. So we can solve K by doing simultaneous equation. Kita boleh selesaikan menggunakan persamaan serentak. So this is our first equation. This is our second equation. So we want to find K. So what can we do? Equation 2 subtract with equation 1. Okay, so kita selesaikanlah. Anda tolak saja seperti biasa. So this will give you K equal 1.5249 times 10 negative 20 joule. So in this equation, remember K ini is in the unit of joule. So we are not done yet. Belum habis lagi because the question want us to put K in EV. Okay, so what is the thing you need to do next? Just to convert. So how to convert joule into EV? Okay, so you will end up with 0.0953 EV. Okay. Okay, so boleh ya, boleh faham kita nak hitungkan nilai K dalam EV. So akhirnya kita dapat daripada kita selesaikan persamaan ini, kita dapat jawapannya dalam joule. So kita tak habis lagi, kita kena tukar dia kepada EV dengan mendarab dengan perkali inilah. Okay, by multiplying the answer in joule with this value. Okay, so you will find the answer in EV. Okay, internet tu putus-putus ke macam mana? Boleh? Pak saya.
Cikgu
Screen screen hilang. Okay, minta maaf Okay. So students, this is the final answer for the value of K in the unit of EV. Okay, boleh faham Okay.
Cikgu Hasnitah, kadang-kadang ada pelajar yang tanya jawapan akhir tu kita nak letak berapa dia punya
berapa tempat perpuluhan.
Tempat perpuluhan yang paling bagus lah.
Macam kita biasa bincangkan Mr. Pip, kita fizik ni paling sikit 2 kan, biasanya kita bagi tahu paling sikit 2 tempat perpuluhan. Selalunya yang cantik 2 to 4 decimal places will be nice lah. Tak perlu terlalu panjang. Okay, tapi tak ada masalah pun kalau anda nak tulis panjang-panjang. Cuma kita takut nanti anda tersilap tulis lah yang dekat belakang tu. Okay, so I think 2 to 4 decimal places will be nice. 2 hingga tempat perpuluhan tu cantik lah. Dan satu lagi paling penting, unit. Jangan lupalah tulis unit. Dan satu lagi pantang dia fizik ni pelajar, jangan tinggal jawapan dalam bentuk pecahan. Okay, never leave your answer in fraction. Terutamanya dalam bab elektrik kan, bab elektrik tu pelajar suka tinggal dalam bentuk pecahan sebab dia sebenarnya dia boleh diselesaikan lagi. So never leave your answer in fraction. Tolonglah letak dalam kepala masing-masing. Sebab sayang kalau kita tak dapat markah yang terakhir itu sebab careless mistake seperti ini. Okay, sama ada tertinggal unit, tempat perpuluhan tak ada ataupun letak satu saja ataupun letak dalam fraction. So sangat-sangat rugilah. Cikgu Yani boleh
Ya, okay.
Okay, so harapnya membantulah sedikit tips untuk bantu. Okay, I think we come to the second last learning standard is to explain production of photoelectric current in a photocell. Okay, kita tengoklah sedikit macam mana arus photoelektrik itu dihasilkan dalam sesuatu litar sel foto. Okay, ini contohlah satu sel foto yang anda boleh dapatkan daripada internet. Sebenarnya Google saja photoelectric effect, ada banyak simulation or animation you can find there. Okay, the first one, what do we have here? Okay, so the cathode. Okay, cathode ini yang C. Okay, you can see the label there, C, cathode. Okay, is coated with cesium connected to negative terminal and the anode ini A. okay, on the other side is connect to the positive terminal of a battery. So this is the structure of our solar cell. Kita punya solar cell, cathode dia itu masih sambung pada negative terminal battery. Okay, and anode must be connected to the positive terminal of the battery. Okay, so cathode ini normally we covered with photosensitive material, barang logam yang sensitif terhadap cahaya lah, for example cesium. Okay, then what's next, apa lagi seterusnya? Kalau anda lihat, mouse dia guna lari. Okay, where do my mouse go? Mouse saya pergi mana? Okay, next. Okay, so cesium was chosen as a cathode due to its low work function. Kenapa kita pilih cesium? Sebab cesium ini dia punya fungsi kerja adalah rendah. Maknanya kita tak perlu tenaga yang begitu tinggi untuk kita lihat kesan dia. So kita sinarkan cahaya pada frekuensi rendah saja sudah cukup untuk mengeluarkan, to see the photoelectric effect occur. Okay, and the lower the work function, more electron will be emitted when the light is radiated on the cesium surface, supaya kita dapat lihat kesan dia dengan cepat lah. Sebab itu kita pilih cesium, metal with a lower work function. Okay, next student, what happened? Okay, if the frequency of the light exceed, okay, so when we continuously supply heat here and it happened that the frequency exceed the threshold frequency of the cesium. Apabila frekuensi foton itu melebihi frekuensi ambang cesium, so anda boleh lihat elektron akan terbebas. Okay, there will be electron released from the cathode surface and it will be accelerating to the anode. Right? Okay, then once it is reached the anode, so the circuit is complete. Apabila elektron yang dibebaskan itu dia tiba di anode, maka lengkaplah kita punya litar. Okay, and we can check on the microammeter here, you can see a reading. It means a current flow in the circuit. And the current produced here is known as photoelectric current. Arus yang terhasil sini kita panggil dia sebagai arus photoelektrik sebab dia terhasil daripada kesan photoelektrik. Okay, alright. Okay, next. Okay, so this is the comparison between cesium and lithium. Apa beza kalau kita guna cesium dengan lithium? Okay, tadi cesium ini is a metal with a low work function, 2.14 eV, while for lithium is a higher 2.5 eV. Okay, and this is the threshold frequency for cesium, 5.16 times 1014, which is lower compared to lithium. Okay, so you can check on the third particular that the maximum wavelength to produce photoelectric current is 578 nanometer. This is the wavelength of a photon. Okay, the wavelength of a photon irradiated, so to create a photoelectric effect is 579 nanometer. For lithium, okay, you can see the maximum wavelength produced is shorter, 496 nanometer. Okay, so you can compare the work function, the threshold frequency, and also the maximum wavelength required to produce photoelectric current for both cesium and lithium. Okay, next. Okay, so itu saja contoh. Okay, contoh untuk how photoelectric current produced by photoelectric cell. Okay, so now from what I show you just now, okay, how to write the relationship from the table I show you just now, how to write the relationship between the work function and the maximum wavelength required to produce photoelectric current. Okay, boleh tengok jadual tadi lah. Okay, so you can check from this table. So what is the relationship between work function and the maximum wavelength? So this is the answer. You can write jawapan dia. So the higher the work function, the shorter. Okay, the higher the work function, the shorter the maximum wavelength required to produce photoelectric current. Okay, because you know why, student? Remember, wavelength ini dia inversely proportional to frequency. Okay, so if you understand, when work function is higher, frequency is higher, which means the wavelength of the photon is lower. Alright. Okay, and next, what is the relationship between light intensity and photoelectric current? Okay, for this one, actually there is one simulation you can check from the FAT Colorado Institution. Cikgu Yani mungkin boleh share link dia, tadi cikgu ada save satu link tapi cikgu tak dapat tunjuk di sini, minta maaf sebab saya takut nanti bila saya tunjuk nanti komputer saya akan lag sebab internet saya tak berapa stable. So I think Cikgu Yani, you can share the link for the simulation on the effect of the photoelectric and the light intensity together with the wavelength. Okay, saya tahun 5 boleh belajar ke Mira Shani? Hai Mira Shani, thank you for joining us. Okay, siapa-siapa pun boleh belajar sebenarnya, tahun 5 ke 5 tahun ke kalau ada minat kan, sebab kalau boleh
minat.
kita nak pupuk dari muda minat terhadap STEM ni kan Mr. P, sebab sekarang kalau kita tengok minat pelajar STEM ni sekarang menurun kan, kita pun sedih sebenarnya sebab bila teknologi semakin berkembang, sepatutnya lah semakin ramai pelajar kita berminat lah untuk mendalami bidang STEM ini, sains, teknologi, engineering dan matematik. Tak ada masalah Mira Shini. Okey, anda boleh tonton. Mana tahu nanti bila tengok kelas ni menyebabkan anda tertarik nak belajar fizik. Dan lagi satu tajuk ni tajuk yang baru, fizik kuantum. Okey.
Cikgu Has, dia nak naik konti tu.
Naik konti. Kalau orang kelas suka naik konti. Betul. Tengoklah kelas semula. Okey. Maybe next time kita boleh. Okay, so this is the relationship. So students, you can check from the link shared by Cikgu Yani. Boleh anda cuba. You can switch the wavelength and switch the type of metal, and you can see the intensity. Sangat menarik ya simulasi itu, anda boleh cuba sendiri. So this is what you will find from the simulation. As the light intensity increases, the photoelectric current in the photocell circuit increases. So bila intensity cahaya itu semakin tinggi, bacaan pada microemitter ini pun menunjukkan pertambahan, means lebih banyak arus yang dihasilkan. Alright, so I think we have come to our last learning standard for today. The sixth one is to describe application of photoelectric effect. Kita tengoklah sedikit contoh aplikasi kesan photoelectric dan yang ada dalam kehidupan seharian kita. Okay, the first one. Okay, LED street lamp, lampu jalan. Okay, semua orang fahamkan lampu jalan ini dia pakai automatic switch. Sana ada fungsi transistor. Okay, and at the same time it is also refers to the photoelectric effect. Dia juga sebenarnya daripada kesan photoelectric. Okay, the LED lamp along the road which are powered by solar cell are energy efficient and environmental. So kita guna solar cell means the current produced there is called as a photoelectric current. Okay, so in daylight, the photoelectric effect of solar cell enable the electrical energy to be stored in the battery, and during night, the LED lamp will be light up with the power from the battery. Dan kalau anda perasan, bila kita lalu di bawah lampu ni, dia akan jadi semakin terang. So that is how the sensor work. Bila ada objek di bawah tu, the intensity will become higher. When there is no passerby, so you can see that the intensity of the light will become lower. So this is one example of applications of photoelectric current in LED street lamp. Okay, then second, okay, this is the biggest solar power plant complex on earth for nowadays. Untuk setakat inilah sebenarnya dia namanya No Complex Solar Power Plant yang terdapat di gurun Sahara Desert. Okay, is the largest concentrated solar power plant on earth just now. So kalau anda boleh Google, boleh nampaklah ratusan ribuan solar cell yang ada dekat sana. So dia assemble in this way. And it is supposed to be finished by 2020. So sepatutnya sudah siap lah kan, sebab sekarang dah 2022. And this plant able to produce a very huge amount of energy, 580 megawatt capacity, which can be applied by 1 million of the resident. So ini adalah salah satu stesen jana kuasa solar yang terbesar lah dekat bumi. Dan mungkin you can Google for more informations from the net. Alright. Okay, and next to the third application, automatic door. Ada tak siapa yang pernah tersepi pintu automatic dekat supermarket? Mungkin timing tak kena. Sometimes adapun alat tu dia punya sensor is malfunction, so accident can also happen. But this is how automatic door function. Okay, kalau anda tengok yang pertama on the first diagram there is a light detector, okay, at the automatic door, which is used the infrared beam and photocell as the switches. Okay, so actually it's a combination of a few concept. Okay, ada transistor di sana and photocell and also the logic gates. Kalau anda ingatkan dulu kita ada tajuk logic gates, tapi sekarang sudah tak ada. Of a few physics okay, in this automatic door. Okay. Is disturbed, maknanya ada orang lalu lah. Okay, so what happened? The photoelectric current in the photocell will be disconnected, so the door will remain open. So this is how the sensor detects. So the current stop flowing and the entrance will remain open. So anda boleh lalu lah. Alright. Okay, macam tu. Alright. Okay, then the next one, this is ISS, International Space Station. Okay, as you can see, IF, yes. Okay, the International Space Station ini 100% using solar cell lah for their electricity supply from the sun. Okay, then if you look at this information here, ISS like the Earth, this is how far is it from the sun, and from this distance it can generate power from the sun about 1.37 kilowatt for every square meter. Okay, and the solar cell ini kalau anda lihat how the solar panel are assembled, the position, how much is used. Okay, solar cell operate using effects, okay, where when the light photon from the sun reach the surface of the semiconductor, so electrons are released from the surface and produce current. As I mentioned, it is a combination for physics discipline, okay, semiconductor and photo cell, okay, so produce the photoelectric effect, generate the electricity in this. Okay, and last but not least, we have a high resolution camera. Okay, dalam ni dia ada sensor, light sensor or image sensor is the main component in this high resolution camera. So what happened? This component is used to convert light into electrical signal. The light sensor is used to convert light into electrical signal, where finally it will be processed to form a digital image. So anda sometimes you boleh ubah, okay, the resolution for your camera. Okay, you want to take a distant object or a very object. So it depends on the amount of sensed by the sensor. Okay, next student. So I think this is our final part, Mr. Pei, Cikgu Yani, before we end our session today. Kita tunjuklah satu contoh. Kita cuba buat satu contoh soalan on section C which carry 20 marks. Okay, section C ini is compulsory. Okay, compulsory to answer because no choices. Ada satu soalan saja in section C, section question 11. Okay. So you are given a diagram 11.1 and 11.2 to show electromagnetic wave directed to a metal surface and an electron is released. So this is what happened in 11.1. And in 11.2, it shows the same electromagnetic wave directed to a different metal surface and you can see there is no ejection seen from the metal. Mean there is no electron release here in 11.2, but there is electron release in 11.1. So the first question, what is meant by photoelectric effect? Apa itu kesan photoelectric? Okay, kalau anda dengar kita daripada mula, so it is emission of electron from where? From metal. When the metal surface is illuminated by beam of light at a certain frequency. Photoelectric ni adalah satu fenomena yang mengeluarkan elektron dari permukaan logam apabila logam disinari alur cahaya pada frekuensi tertentu. Okay, ini definition untuk photoelectric effect, kesan photoelectric. Okay, next question. Okay, this is a question which carry 5 marks. Okay, you have to compare the two diagram and write a relationship on a few particular. Okay, ke alam baca soalan dia, observe diagram 11.1, 11.2, compare the photon energy and work function. Okay, and then relate photon energy and work function to make a deduction of relationship between photon energy and kinetic energy of electron. So we compare what we can see first. Okay, so in diagram 11.1, electron is released and no electron released in 11.2. Okay, this is what you can see. Okay, then second, you can write the photon energy in both diagram are equal. Why equal? Because they are irradiated by the same sources of photon, same sources of light. So the energy of the photon is the same because same frequency or they have the same wavelength. Okay, means same sources of photon. Then we compare the work function of both metal. Okay, so the work function are not the same because they are different metal. Remember, each metal has their own work function. And next, we relate. Okay, 11.1, the energy of the photon is greater than the work function of the metal. That's why electron is able to emit from the surface. Meanwhile, what happened in 11.2, the photon energy is lower than the work function of the metal. That's why you see there is no electron able to release from the metal surface. And finally, we can write the relationship. The higher the photon energy, the higher the kinetic energy of the electron. Okay, the higher the photon energy, the higher the kinetic energy of the electron. So you can screenshot for the full answer, or later you can come back to this video on this part for the full answer. So the first mark, second, third, fourth, and fifth mark. Okay, next student. Okay, this is application on concept, normally carry 4 marks. Okay, you have to explain how solar cell convert solar energy into electrical energy from the diagram given in 11.3. Okay, so how to explain, student, how solar cell convert solar energy into electrical. So where do we begin? Actually, you can begin with the structure of a solar cell as we discussed before. Solar cell consists of glass vacuum tube with a large metal plate as a negative terminal. Okay, the cathode. Okay, remember the cathode is the photosensitive material. It must be connected to the negative terminal, cathode. And second, you can talk about the anode. Okay, the positive terminal, okay, is smaller in size. Okay, smaller size positive terminal, anode. Okay, then what happens? Solar cell or the cathode irradiated with light. This is how the process begins. Okay, we irradiated a photon or light sources to the cathode, which is the solar cell. Okay, then when the photon energy is greater than the work function, so electron will be emitted. Okay, so this is how the process begins. So what will happen to this electron later on? These electrons which are emitted then will be attracted to the anode. Okay, and once they reach the anode, the circuit is complete. So photoelectric current is produced. So you can see the sequence from one to another. And finally, you can add an additional point here. So single solar cell can produce approximately up to 0.5 until 0.6 volt. So which means we require more solar cell in a series connection to produce higher voltage. So this one is an additional point you can add. So the maximum mark for this question is 4. 4 markah maksimum lah. Tapi daripada apa kalau anda tulis seperti ini, you can get about 5 marks, so more than maximum. So it can secure you 4 marks for this question. So you started with the structure. Where is the cathode and which one is the anode, okay, and what happened when the cathode is irradiated with photon. So when energy is greater than the work function, so you can say electron is emitted, and then this electron will be accelerated or moving to the anode. The circuit is complete, so photoelectric current is produced. Okay, and our final question is on modification ataupun mereka cipta. 10 markah untuk soalan ini. So you are given an example of solar panel, solar cell in diagram 11.4. So you have to you are required to modify. You have to modify this model so it can generate electricity with more efficient. So they give you the aspect here from the mass of the solar, the maximum height from the ground, the hardness of the solar cell, the rotational angle of the solar cell, and the shape of the solar cell. Ada 5 aspek. Anda baca satu persatu, gariskan setiap aspek. So you miss no point when discussing the modification. And you are highly recommended student to give your answer in a form of table. Okay, sebab apa? Senang kita nak tengok dekat mana kamu punya point. So easy for the marker to help you to get mark. Okay, janganlah tulis karangan panjang, a very long paragraph, especially when handwriting is very small. Kadang-kadang kita nanti kita akan mark online kan. So kena berhati-hatilah. Kalau boleh, kalau exam tu besarkan sikit tulisan. Betul tak Mr. P? Sometimes tulisan sangat kecil, kita nak baca pun sangat susah. Okay, so kena practice lah write in a magnified size of font size. Kamu tu kalau boleh besarkan sedikit. Okay, so we have 5 aspect here student. The first one, mass of the solar cell. So senang saja, want to use big size or small size mass. So we are choosing to use small mass. Okay, bukan size mass. Low mass or you can say small, kecil ataupun rendah. Jisim dia kecil, rendah. Kenapa? Fikir logik. Okay, logik. Bila mass dia kecil, so dia lebih ringan. Okay, so bila ringan, mudah dipasang. Cost dia pun agak rendah. Light, easy to install. You can say less cost. The first answer itu is the priority lah. Jawapan pertama itu yang keutamaan kita. Okay, now maximum height from the ground. Where to put the solar cell? Higher or lower on the ground? Tadi anda lihat kan no complex, semua letak di bawah tanah saja. Okay, so we can write lower, rendah. Okay, lower. Okay, simple. Why? More stable. Okay, more stable. Okay, then the hardness of the solar cell, kekerasan dia. Okay, it must be hard lah, mestilah keras. Or you can say high hardness, keras. Ataupun kekerasan dia tinggi. Kenapa nak pilih keras? Supaya dia tidak mudah rosak, tidak mudah pecah, not easily break or spoil. Okay, and the rotation angle of the solar cell. Macam mana rotation dia? Okay. So normally we choose so it can rotate at the fixed end and always perpendicular to the sunlight. Okay, rotating at the fixed end. So berputar pada tempatnya ni dia boleh putar 360 darjah. Okay, and sentiasa bersudut tepat dengan cahaya matahari. Okay, mean dia flexible lah, boleh follow the direction of the sun, always facing 90 degree perpendicular to the sun. So dia dapat maximum light intensity from the sun. Okay, kenapa? Supaya penukaran tenaga cahaya kepada tenaga elektrik lebih tinggi. So more conversion of light energy to electrical energy, mean the current generate will be greater when the light intensity catch from the sun is at the maximum at 90 degree. Okay, then the shape of the solar cell, bentuk dia, nak bentuk macam mana? So ini jawapan yang disadangkan, square shape, small thickness and crystal surface covered by glass. Bentuk segi 4, ketebalan dia kecil, mean dia nipis, permukaan kristal dia dilapis dengan kaca. Kenapa nak lapis dengan kaca? Sebenarnya as a protection shield. Okay, from the weather or any other external factor which can spoil them. So untuk apa susun banyak sel solar dalam susunan sesiri, ini bentuk dia lah, and then cahaya mudah masuk ke dalam kristal bila ada kaca ini. Okay, arrange more solar cell in series, easy for sunlight to penetrate through the solar cell from the glass surface. Okay, so as I mentioned, this is the recommended answer, jawapan yang disadangkan, and the format of answering as well. So kalau boleh soalan 10 markah for section B and C, cubalah jawab dalam bentuk jadual. Okay, so student, I guess that's all for today. It's a very long distance. Sekarang sudah hampir 3.30, but overall thank you very much for your time. Alhamdulillah kita telah habis semua konten untuk tingkat 5, dan boleh mula video di channel cikgu ataupun channel cikgu tingkatan 5 ini. Anda bersedia untuk percubaan SPM dan sebagainya. Dan untuk subjek tingkatan 4 boleh rujuklah juga di channel-channel lain, Cikgu Izyan, Cikgu Nora, Cikgu Rina, Cikgu Rosemawati dan juga Cikgu Faizahz. Okay, so harapnya perkongsian ini membantu anda sedikit sebanyak untuk memahami tajwid ini. So I think that's all for me. I pass back to the moderator, Mr. P.
Okay, terima kasih kepada Cikgu Hasnitah. Saya rasa satu penjelasan yang sangat simple dan mudah dipahami, especially kita rasa bab 7 ini rasa sangat susah kan. So saya rasa Cikgu Hasnitah dapat sampaikan dia dengan sangat mudah dan berbagai contoh yang juga anda boleh lebih mudah terap dalam chapter inilah. Okay, so selesai kelas kita pada petang ini. Tanya dan terima kasih ucapkan kepada semua yang setia mengikuti kelas dari awal sehingga saat ini. Sebelum kita tamatkan sesi siaran langsung ini, mohon tutup rangan cek, klik butang subscribe dan aktifkan ikon loceng supaya kamu tidak terlepas sesi kelas Cikgu Hasnitah yang seterusnya. Sila klik like dan share link kelas kita hari ini kepada rakan-rakan di media sosial anda. Mudah-mudahan pelajar boleh kebaikan di atas perkongsian tersebut. Link sijil telah diletak pada ruang chat. Sila ambil perhatian, link tersebut akan tamat dalam tempoh 30 minit selepas live ini. Pastikan anda login dengan email ed@moi.guru dan Jawi. Sebelum cikgu tamatkan kelas pada petang ini, cikgu persilakan Cikgu Yani untuk sampaikan sepatah dua kata. Cikgu Yani.
Terima kasih kepada semua yang setia bersama kami sehingga ke akhir siaran, dan bagi yang akan menduduki peperiksaan SPM yang paling penting pada tahun hadapan, cikgu mengucapkan semoga berjaya, good luck, terutama untuk subjek fizik.
Okay, so apa lagi kata-kata akhir daripada Cikgu Hasnitah?
Sedikit saja Mr. P. So ini adalah kelas kita yang terakhir sebelum kita bercuti, dan mungkin kalau Mr. P rajin ke dia nak buat kelas sendiri ke bolehlah, ataupun kalau cikgu pun ada masa, kita tengoklah kalau ada live tu anda follow sajalah. Okay, tapi masa cuti anda manfaatkanlah dengan sebaiknya. Okay, gunakan masa, dan kalau banyak sumber di internet kan kita boleh dapat sekarang ni, di hujung jari saja banyak soalan-soalan percubaan. So jangan sia-siakanlah peluang itu, semua boleh dapat, kebanyakannya boleh dapat secara percuma saja sekarang ni, anda rajin atau tidak saja. So sebenarnya nak berjaya tu bukanlah susah sangat pun, anda nak ataupun tidak, kemudian anda rajin ataupun tidak. So kalau kita nak, kita kena usahakanlah benda itu sebaik yang mungkin. So pesan cikgu, yang penting jaga kesihatan, jaga keselamatan cuti-cuti ni. Jangan seronok-seronok sangat pergi mandi-manda sana sini sebab musim hujan kan sekarang ni, musim terkujuh. Keselamatan tu kena utamakan, dan anda perlu sihatlah untuk menduduki peperiksaan dengan aman nanti pada bulan 2 nanti. So kita jumpa lagi dalam kelas-kelas yang akan datang insya-Allah, dan selamat bercuti semua dan selamat maju jaya. Terima kasih.
Selamat bercuti.
Okay, so terima kasih daripada Cikgu Hasnitah. So saya pun rasalah kita punya team Form 5 kita sudah habiskan silibus kita. So walaupun cuti 3 minggu, anda bolehlah tengok balik daripada bab 1.1 sehingga bab akhir ini. Dan kita akan kembali lagi selepas cuti ini dengan ulang kaji Form 5. Okay. So terima kasih kepada semua penyokong Akademi Youtuber. Doakan kami terus kuat dan bersemangat untuk membantu dalam membangunkan pendidikan di Malaysia. Sekian daripada kami. Salam hormat dan jumpa lagi. Bye-bye.
Bye-bye.
Tuisyen online percuma. Tuisyen online percuma. Layari www.akademiyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi Youtuber. Rujuk jadual di laman sesawang www.akademiyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi Youtuber.